Well, g'day, flatties and reality defenders. This is the legendary CT from Down Under. Okay, thank you. So this picture is taken out the left side of QF28 after leaving Santiago, and that is the mountains on the east coast of South America. Right, that's relevant to today's video at least. So today's video, we're still continuing with the 3 or maybe 6 Bitcoin challenge, and this is the FAQ video 1. And let's hear what Dave has to say about all of this.
Watch the daily video while you have your morning coffee, breakfast, whatever, and one just every day for 2 weeks. At the end of that 2 weeks, if you think the Earth is a globe, you can send me your proof and you win 3 Bitcoins. But before you do, you have to hit the question mark button. Mm-hmm. And that opens up the frequently asked questions so you don't waste my time. Okay? People are like, you got to have your Bitcoin in escrow. You got to have a contract. No, I don't. Okay? My honor. Right? Before you go, well, how do I know you're going to pay? My reputation, my everything is on it. Like, if I don't pay, then, I've ruined everything.
I swear on my life, I will pay you 6 Bitcoins for 1 globe proof.
Yeah, sounds a bit incredible, doesn't it? Right. So today's video is a video that was from Jeranism. It's labelled Santiago to Australia, but this clip out of Jeran's video, which is copied onto the Flat Earth Sun and Moon Zodiac Clock app, doesn't actually mention Santiago to Australia. But we do mention it today, so I'll leave that bit in the title and correct the title there. Santiago to Australia is impossible on a flat Earth. Now, this video has been taken down by Jeranism because he no longer thinks that it is correct. So on that basis alone, we could dismiss it, but we're going to go through and discover why it's incorrect. So let's get into the video.
25,000 mile circumference of the equator. So let me go with a circle here.
So there is the mistake. This is a mistake which will affect the whole video there. So the 25,000 mile circumference of the equator, that's the globe, right? The globe. Not flat Earth. Flat Earth has a different circumference. So right there, off the bat, we can see that he's out on his flat Earth numbers. So on the flat Earth, the distance from the North Pole to the equator is 6,215 miles. We'll do this bit in miles because he talks in miles. And so that means the flat Earth equator is 2 pi times 6215, which is actually 39,049 miles, which is a long way from 24,901 miles. And that's an error of 1.57 times. So this, all Jeran's numbers are now wrong. But let's carry on.
Circle. And let's go circle. Okay, so we're going to put this out to the equator, which is where? Let me show you. So the equator is about there, right? And that kind of covers it all. Okay, yep. So there's your equator, is the outside of this circle. And so we're really looking for now the curved spot from here to here, knowing that that makes that 12,000 miles, right? If we go here and we're going to grab this.
Close enough.
To there. So this line is going to be 12,500 miles in a second. As soon as I finish getting it in order.
Sorry, no.
Okay. So that line right there is 12,000. I should be able to move it. Okay. So this orange line here is 12,000. So look at the distance between. Come on, don't lose that. So let's look at the distance between that flight we just looked at. So that flight leaving for Johannesburg and coming to right here.
I think this is cut out of a longer video. So the flight that he was looking at is Sao Paulo in Brazil to Johannesburg.
Is what? So it's certainly not 12,000 miles. It's certainly not. Oh, let's see if we can separate it by those spaces. So we got 1. So we said this is 12,500. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8. Let's go ahead and figure out what that would be. So if we have 8 of those little dots, 12,500 miles divided by 8 equals, so 1562 each section.
Remember that.
So 1562 each section. We grab that, we put it onto, I guess Johannesburg's probably right here. Let me move it to where that green dot is right on top of it. What would you say there? Is about where Johannesburg is? Let me go back to here and see if we can see. Yeah, it's about there. So we're going to go there to, and figure right about here. If we kind of swung this up, it's not really possible for me to turn it. Let's get it more like this. That's still a little bit off. So if it was here, it would be 1, 2, 3. See that? 1, 2, 3. And if you want to give it a little bit more airing on the side of the globe, maybe 3.5, right? So 3.5 times our number, that would we come up with? 1562 times 3 would be 4687. And what did we say that the miles were on the globe? So what's ridiculous is to ever just claim that, oh, I looked into flat Earth, and because these flights are impossible. What is impossible?
So just to clarify there, Jeran's making a mistake here, and the flights, while these ones may be capable of being within an aircraft's range, it's impossible to fly them in the time allocated.
We have 4623 on here. There you go. And we just came out with 4687 by multiplying it by 3. Now you might say, oh, Jeran, that's 3.5. Okay, so add half of that was 700. So now we're looking at 5200. Easily done through planes that go higher than we expect, go faster than we expect, take the jet streams when we don't expect it. Jet streams, I have papers, I've shown it before, I can show you again. There's links in the t.me/Jeranism links that say, by somebody who was a scientist who was doing studies on the atmosphere, who says that we have up to 350 mile per hour jet streams in the south.
So just to clarify, that up to 350 mile jet stream could mean that at some point during the year, maybe even just for 1 second, the jet stream reaches 350 mile an hour. That does not mean a constant 350 mile an hour jet stream, just to be clear on that.
So why is it that now we're told they're only 250? Well, because 350 might make the lie more obvious. So
no, that's not true. That's because 350 is not an accurate number. And when we're talking about average jet stream, 350 is not correct. Nothing to do with propagating any lies or anything.
This is not a problem flight for the flat Earth.
Only because you've done the numbers wrong. So let's just check this. So your error, as we pointed out, is 1.57 times. So you're claiming an AE distance of 5,200 miles based on you're moving a curve around the map. So if we correct your error, then your claim should be 8,164 miles. But if you actually do the calculation correctly, the actual distance on the AE route, this is flying the route that it does not fly, is 9,599 miles. And if you fly the route that we know it flies, because we get coordinates from the tracking of the aircraft, then it's 10,663 miles. So that's a hell of a lot of difference with a globe route, 4,615. So the plane would need to be flying at least twice as fast, more than twice as fast. And thanks to Ruif for these numbers here, he calculated them out for me. And so jet stream 250 mile an hour it's never that high constantly, and it's not always in the tailwind direction. So yes, that makes this flight a problem on the flat Earth and impossible on the flat Earth, because it cannot fly so fast in the time that it takes for this flight. So yeah, that part's all wrong about Sao Paulo to Johannesburg. Yes, it's if you do the numbers correctly, it's impossible on a flat Earth.
this flight here is if you listen to this guy talk, he'll say in a second that it would take 24 hours to make this flight on a flat Earth. What's he talking about?
Well, that may not necessarily be correct, but it's going to take a long time, much longer than it really takes.
What are you talking about? How would you even say that? If this line here is 12,500 miles, because the circumference of the equator is 25,901.
No, it's not. You see, you made a mistake there, remember?
This stick out and use it as a barometer or use it as a measuring device, and you'll figure out that you're wrong about that.
No, you're wrong about that. The flat earthers, they all speak so confidently, thinking that they cannot be wrong, but they are wrong. And yeah.
Now, the other one that he will bring up here in a second, we'll talk about that, is this one, the Sydney to Santiago. And I'll show you some reasons why the flat Earth has more evidence than the globe as far as that goes.
No, the globe has far more evidence. Again, you're making a mistake, but we'll get to what the actual mistake is.
If you're taking this flight, okay, and I've always said I don't think that it goes across the United States. It probably does.
No, it doesn't. Thanks for acknowledging that.
Something more like this. If you want to see what the flight really does, kind of like this.
No, it doesn't even do that either. It goes south of New Zealand and sometimes crosses the South Island of New Zealand. Goes much further south than that. So, no, that's incorrect as well. And we have the tracking data. Not only do we have the tracking data, we've got people sitting on the plane that can verify where the plane actually flies. We'll get to that another day, but we'll get a little bit of that today.
Okay, that's kind of the flight path it would take. And if we look it up, we're going to see that the flight does 7,000 miles. 7,000 miles.
Okay, that's
in
okay.
Usually about 12 and a half hours. Okay, let's go 12.5 hours. All right, so we multiply that out. We do 7,000 divided.
Actually, the average time is just over 12 hours, but we'll carry on.
By 12.5 to figure out how fast that plane would be going, and we get 560. Okay, clear this out. So that means that this plane that we know of goes 560 miles per hour. Okay, but here's the problem. This is where globers are believing in fantasies.
No, you're just plucking some figures out of your rear end, and this is who's living the fantasy here? We globers use actual numbers and verified numbers, not ones that have been plucked from a certain region.
If there is a up to 350 mile per hour wind.
No, there isn't. And if it was up to 350 mile an hour, it would not be a constant 350 mile an hour.
Blowing this way. Okay, but we're now told it's 250.
Well, even 250 is high, right? Because Jeran's done no investigation, no research on working out what the jet stream should be. Plus, he's also forgotten the obvious in that what happens when you fly the other way. But anyway, we'll get to that.
Okay. Okay, let's just give it to them. Let's just say it's 200 miles per hour. Here's what you dumb must believe. That the plane is actually going 360 miles per hour.
You see, notice that Jeran gets a little bit excited about this. He's very emotionally involved in the topic, and is in those days, he was very keen to stick it to the globers.
Even though it can do twice that. For some reason, this plane, out of all planes, that's flying the longest distance, all of a sudden said, no, it. We're going to go way slower than any other plane in the sky.
Well, all of that is incorrect, of course. So all your ranting there is to no avail because it's based on incorrect facts.
We want to go 360 miles per hour, and then we're going to add 200 miles per hour to our speed with the jet stream, and we're going to go 560, and we're going to get there in 12 and a half hours. Or does it make more sense that you take the 200 and add it to the 560? and all of a sudden that plane is going 760 miles per hour. And then you take 760 miles per hour and multiply that by 12.5, and all of a sudden that plane is going 9,500 miles. Do you see the?
That's still not enough, 9,500 miles. Okay, the flat Earth distance is longer than that, but we'll get to that.
Point. You believe in a fantasy, not us.
This is why Jeran had to retract this video. He now thinks differently about that.
I believe that planes tend to go as fast as they can to get where they want to go.
No, they don't. They have consideration about cruising speed, which is the maximum economical speed they can do, and they have to leave a little bit of leeway so as not to exceed their maximum operating speed, maximum operating airspeed, because that's bad.
60 when they can go 620 and just go, we're just going to go, we're going to lollygag and get there. No, this is the evidence that you need. You guys are too stupid to see it.
That's not evidence. That's just you writing some stuff on an AE map with a crayon. That's not evidence. You've done no proper investigation. Oh dear.
All of you globers are too tiny, bald, little sucked up in your abdomen that you can't even fight against known liars who are lying to humanity.
Oh dear, Jeran, such a foul-mouthed person there. Why? Why are you getting so excited about that? Especially now in the view that we all know what you just said is wrong. So, this is a message to all flat earthers everywhere. Be careful. You just may be wrong. And even though you think you're infallible, you just may be wrong. So aren't you going to look stupid one day? Oh, actually, sorry, you already look stupid already. Sorry I said that.
You are protecting these liars. You are protecting.
There's no lie. We'll see.
Protecting them. Sickening. Sickening. I mean, how many are you going to jump off roofs when you realize what you've done? That's my question.
Oh, except that we're in the right here.
Okay, I'm not backing any known liars that are hurting humanity. You are. Do you understand the difference? Doesn't matter how many times you call me a grifter or think I'm lying. No, I'm not the one lying. Your governments are. And
yeah, well, maybe the governments do lie about something, but we're not lying about the globe, as you already know now.
If you're too stupid to see that governments lie, then you're too stupid to be on this show. Get the hell out of here. I'm not lying when I just gave you the details of that flight.
No, I agree. You're not deliberately lying. But there's a certain amount of intellectual dishonesty going on there because you haven't done a proper investigation.
I'm not lying when I tell you what the speeds of the jet streams are. I'm not lying when I tell you that they can get up and they use the jet. Every single plane in the sky uses the jet streams.
Yeah, but just remember it's only going one way and you're mistaken about the speed.
At least passenger jets. Every one of them. Okay? So pay attention.
Yeah.
You do not have planes that are going the longest distance in the world that are going drastically below their top speed.
All right, no plane flies at its top speed, right? It has a cruising speed. But anyway, minor point.
Which is what you have to believe that the globe is true.
No, I'll show you soon. That's not what you have to believe at all. So Jeran's assuming that there's a 200 mile per hour constant, never changing jet stream that's always on the tail end of the aircraft, which is not true. And we've got more evidence of that. The other thing Jeran is forgetting there in that video is that the jet stream is west to east always. So let's just say it was 200 mile an hour. Then your cruising airspeed is still 562 mile an hour, and the ground speed would then be 362 mile an hour in the reverse direction, because remember, flying in the other direction, you're flying against the jet stream. So the flight distance is still 7,000 miles roughly, So the length of the flight would be 19 hours. Oops. Then the flight doesn't take 19 hours. So yeah, the specs of the 787 Dreamliner, which is the plane they use on this flight these days, says the cruising speed is a Mach 0.85, and all the flight plans for this flight show 0.84 or 0.85 Mach, and cruise altitude 35,000 to 43,000 feet. So they don't go higher than 43,000 feet, and where the higher jet stream speeds are, so we can't use the higher numbers. And Flight Radar 24 shows us that QF27, which is from Sydney to Santiago, has an average flight time over all the flights of 12 hours and 4 minutes. And then the one in reverse, Santiago to Sydney, which is flying against the wind, has an average flight time over all those flights of 13 hours and 40 minutes. So when we say the wind only goes in one direction, this is backed up by the data, which shows that the return flight always takes longer. So the average is different by about 1 hour and 40 minutes, or 1 hour and 36 minutes to be exact. So yes, so when you get the jet stream only going one way, the higher the jet stream, the bigger problem you have in making this flight fit on a globe or a flat Earth. So it doesn't fit on the flat Earth already, but to try and make it fit on a globe with a mythical jet stream that goes too fast, it's impossible, as I'll show soon. So just to sweeten the pot a bit, the return flight, QF28, often goes close to the coast of Antarctica. And these photos taken by one of the crew members on QF28, I'm assuming, because QF27 rarely goes that south. And the day that I flew, there was too many clouds, couldn't see a thing. Pity. Now, I took data from 5 actual flights each way. I've loaded them into a spreadsheet and I worked out various stats. Now, I'll show the spreadsheet. So this one's for QF28. So here you can see I've got the data that we get from the flight radar or flight aware is this kind of data here, which we get a timestamp in, I think that's seconds, the UTC time, what the aircraft call sign was, its position, its altitude, speed, and direction. And then I calculate from this, I use the hover sign to calculate the globe distance between one reading and the previous one. So that's why this ends up being a value, because there's no previous reading here. And I've got this speed greater than 25, which eliminates all the taxiing and stuff and only counts flying time. So it starts here, there's only flying time. So the it gives the globe distance. The flat distance is calculated using the polar coordinates, and I've got the code for that here. So this is a macro here for calculating the distance on the flat Earth using polar coordinates, because on the FE map, the lat long are polar coordinates. So all these numbers, now QFA28 headed south, pretty close to south at first, and so the globe and flat speeds are the same, because on the AE map, heading south is the same distance as the globe. So as we get down further, and when we start to head down near Antarctica, we start to get bigger numbers. And then we get down here we're approaching the Antarctic Circle, and we actually go below it a little bit on this flight. And this plane has to do 6,000 odd kilometres an hour to be able to traverse that distance on the flat Earth. So you see, that's impossible. That's ridiculous. Even if your plane was a special plane, it's not going that fast. And the winds are this is heading into the wind, and there is no tailwind on QFA 28. Well, it may be very little in sections. So add all these up, and down the bottom, I got the time, flying time, 13 hours, 0.38, which is about, 13 hours 40, a little bit more. And the globe distance, 11,696 kilometres. The flat Earth distance, 42,000 kilometres. This is calculated by taking the distance between each of those logged data points. And Walter Bislin has done a similar calculation and got similar results. So I know this is pretty correct. So the ground speed is an average of 874 kilometres per hour. And the flat Earth ground speed, you have to go an average of 3,140 thereabouts kilometres an hour if the Earth were flat. And you have to traverse that path because we know that it goes that path. So the coordinates are all correct and verified based on many factors, including visual verification of location. So I've done this for 5 flights in either direction. And the average of those 5 flights, QF27 average agrees with that one there on Flight Radar 24, 12 hours and 4 minutes. The QF28 average is very close to the Flight Radar 24 average of 13 hours and 14 minutes. So these figures here, which shows the average flat Earth speed required, 3,000 kilometres an hour. The average flat Earth distance, 39,000 something kilometres. And worked out the tailwind required. So based on these flight times here, which is average 12 hours, in order to achieve that flight time, the flat Earth flight would require a tailwind of 2,000 kilometres an hour, more than 2,000 kilometres an hour. So in the globe, the tailwind works out to be an average of 55 kilometres an hour. So not the 200 mile per hour you're thinking, Jeran. The numbers here all calculated from the actual flights. So the globe is 55 kilometres an hour average tailwind, and the headwind on the return journey is 48 kilometres an hour headwind. Now these numbers are a little bit skewed because on the return pilots choose a path that minimises headwind, and on the flight over they choose a path that maximises tailwind. So in general these will be different because of that. Now the interesting thing, of course, is that on the flat Earth you require astronomical tailwinds in both directions. And we know that the jet stream only works in one direction, and it certainly does not go thousands of kilometres an hour. So that's why we say that this flight shows that the flat Earth is impossible and proves the globe, because everything here works on the globe, nothing works on the flat Earth. So just here for your understanding, the flatties will often quote jet stream as the magic thing that cures these southern flights, but it's a double-edged sword because it only works in one direction. So if you're going to jet stream the flight you have to say that you're going against the jet stream in the other direction. So for this QF27, this is plot here of the flight time versus the speed of the jet stream. It's in kilometres an hour. So the blue line here is QF27. The orangey coloured line is QF28. So as the jet stream, average jet stream gets higher and higher, you see that there's a greater discrepancy. So for example, this 175 kilometre an hour average jet stream, which is much lower than the 200 Jeran was saying, would require you return flight to take 16 hours. And then the flight there would average less than 11 hours. So Jeran's talking in this area down here, right to the right side of this graph here. He thinks the jet stream is that big in that video, but then it would have a consequence of the flight back being something like 19 hours, which is ridiculous. So you can see here at a jet stream around about the 55, we get the flight times that we see in reality. So these are the figures in reality. So Ruoff has put out an excellent video talking about these flights. He's done all the numbers. So I highly recommend you go watch that video if you have not. It's a more comprehensive breakdown, and also it's another method for working out the average jet stream that's different from my method. But he plots the actual jet stream velocities from a database and he worked out that on that flight, that particular flight on that day, which is 2024-08-16, there was a 55 mile an hour average tailwind, which translates to 88 kilometres an hour. That's a little on the high side, but I did get a flight with 98 kilometres an hour in my data. So it's still a good match, considering that this is an approximate method and the jet stream varies from day to day. Anyway, that's my comprehensive debunk here with this video. The southern flights prove the globe. This video has several errors, and I've shown by using real data the flight is impossible on a flat Earth and proves the globe instead. Thank you.